The technique that we just looked at is fine and dandy if I'm burning a fuel, but often we're not burning things. So often we're using water, we've got things in solution. So this is an example of how else we can do it. We use a polystyrene cup, or something like that, a polystyrene because it's nicely insulated. Into that we have a thermometer, so the same as before. We record the temperature at the start. Let's say the temperature at the start, so start temperature, let's say it's 21 degrees C. We are going to do this reaction, so it is copper sulfate plus zinc, giving me zinc sulfate plus copper. So how do I do that? Well, I measure out 100 grams of copper sulfate solution into my cup, and I add in excess zinc. So that just makes sure all the copper sulfate reacts, and I know I've got 0.15 moles of copper sulfate. So that is of copper sulfate. And you just do exactly the same thing. So I do that, let's say the end temperature is 26 degrees C. So the energy released in joules, we use the same equations before. The mass of water, we assume is the same as a mass of copper sulfate solution. We don't worry about the fact we've got copper sulfate in it. So that's going to be 100. The specific heat capacity we assume is the same, and the temperature change now is 5 degrees C. So, okay, so that comes to 2,100 joules, which is going to be 2.1 kilojoules. So we've got that. Now, I've told you how many moles of copper sulfate. Do I need to worry about how much zinc I added? I don't, because I added excess, so as long as I've added enough. So delta H is going to equal 2.1 divided by 0.15, which is my moles. So if someone could whiz that in a calculator, 2.1 divided by 0.15, that comes
14.
to, how much?
14.
14, wow, okay. 14 kilojoules per mole. Did my temperature go up or down? It went up. So what sign do I need here? I need a minus sign there.